My name is Xavier Pasco. I'm very pleased to welcome you here. We're going to talk about these very interesting subjects with our panelists. We had too many people in the room yesterday. We didn't have enough chairs in the room yesterday. As the time goes by, we may have some more people arriving, and so I'll be able to ask for some extra chairs. We have another room available in the d'Urberville room, where this panel will be broadcast. So, welcome to this discussion and presentation on a long-standing issue in warfare. We often talk about the sword and the shield. And today, the question we're asking is, are offensive weapons overtaken defensive ones? This question is becoming more relevant today because of the recent events. We've talked about this a great deal yesterday already, about everything we know about the developments in international conflicts between Russia and Ukraine, and the different conflicts that have also occurred since then. All of this represents an upheaval in our certainties that we had previously during a period where, above all, there was a combat against terrorist attacks and an extensive conception of security and defense, which ever since the attacks of 2001 had put to one side the high-intensity conflicts. And often events mean that high-intensity warfare is now once again very much in the news. And of course, the war in the Ukraine has been the most striking aspect of this new development. And so in the series of questions we're looking at during these few days about technological developments, this means we need to talk about the role of offensive weapons and the need to reevaluate the role of these offensive weapons in high-intensity conflicts today. And we have to look at this dialectic between offensive compared to defensive. There's always a question of the art of war. There are also technological developments that we can observe also at every level of the conflicts, whether it's in terms of intelligence, communication, and when impacts are produced in the theater of war. We have to realize that all of these technologies are changing more and more quickly. So before the defenders and attackers, who are all both benefiting from the same technological developments, what is now the balance between these two? From my point of view, and I look at this from a specific point of view, because in my fields of interest, which concern the space above all, we can realize, for example, this is just an example, and this is a way of starting our discussion. We realize that we are in a kind of race to reduce and shorten the length of cycles. You are familiar with this ODA loop, observation, decision, and action. We've always known that the shortening of this loop is one of the things that we need to do to ensure military prevalence, and that the confrontation between military players in the field is very much affected by the efficiency of this loop. And with the development of technology and digitalization and acceleration of communication in real time and reduced latency, we realize that everything is tending towards reducing these loops and shortening these loops as far as possible, which we have a hyper-automation of our conflicts. Today we'll talk about AI a lot. We talk a lot about acceleration. So this is a question that is being raised today. How is this dialectic developing? Where are we in terms of these technological developments and their impacts on the art of war? So I'm very pleased to be able to welcome today three distinguished specialists who are at the heart of these issues and the efforts that are taking place. First of all, was Xavier Mesnet, who will be our first presenter. We'll have 3 presentations, then we'll enter into a debate and a conversation. And of course, the audience is welcome to participate in that as well. Then we have Xavier Mesnet, who works for Thales. Director of the Naval Program and of the Naval Segment at Thales. He was Director of Naval Strategy at Thales Defense Mission Systems, and has a huge experience in the naval domain, and he will be giving us his view and his vision. And then we have Unique Thomas, who is a program manager for C2 activities devoted to ballistic missile defense at Ariane Group. He will be giving us an idea of his approach and his vision of the current situation, talking about the confrontations of a strategic nature. And then finally, we have Laurent Duport, who is at MBDA, he's Director of Business Strategy, in charge of the missiles and systems product portfolio. He's held senior positions in software engineering and systems engineering in the fields of missiles. So we have 3 specialists with us this morning who will, first of all, give you an idea of their approach to this question, which is not an easy one to talk about in the current context. So without any further ado, I'll hand over now to Xavier Mesnet to give us an idea of his approach. Thank you very much, Xavier. It's quite a difficult question. I have a few slides in case what I'm saying to you is not very interesting. Concerning the opposition between defense and offensive weapons, the first thing we need to say, we talk about arms, weapon systems. This is a question of detection or the explosion of the munitions with its all of the self-directing systems, and right up, starting with initial detection. This is a completely coherent system in weapon systems. So really this is how we define the performance. So I extend the question of a weapon to a weapon system. That's very important. We focus mainly on some of the links in that chain. My colleagues will also explain that to you. The second thing, that's why it's interesting to have different points of view, is that one thing we have to talk about is coherence between what makes it possible to detect the threat and what makes it possible to process it. If we have radar defects at 500, 600 kilometers distance, but the weapons can't reach that target, what is the point of having a radar system that can do that? So there's a concept of a chain, which is very important. I always try to simplify as far as possible. Often in the audience, people find what I say it's too simple, but I think it makes it easier to explain. If we talk about defensive weapons, normally talk about two things. Self-protection, which is often quite close, and then I would say during this period of peace, we haven't worked on this aspect enough for a number of reasons, and after that we've had a period of zonal defense, and over the last few years a lot of work has been done on that, especially on the air defense frigates, making it possible to defend whole zones. And in that case we have a limit between this is where they have the border between offensive and defensive. And what has changed, the Ukrainian conflict is interesting because we have 2 armies of completely different sizes which have been fighting and there's lots of information we can take away from that. We have the return of anti-vessel missiles. You've seen that through the Kosovo incident. We can talk about that. The Russians were not very well prepared for this threat. This is probably one of the reasons why the missile was able to reach its target. We have the return of anti-vessel missiles, which had been abandoned to some extent. This is one of the most difficult missiles to deal with because it's very close to the water And so the decision has to be taken at the last possible moment in very short deadlines. They're very agile systems as well. And so to combat these systems is one of the most difficult things to do for vessels. Secondly, we have the hypersonic missiles, very specific hyper missiles fired from aircraft. And this has started to introduce these missiles, which are Mark V missiles. This raises specific problems because they move very quickly and they are fired from a long way away. There have been other changes as well. We've seen the increasing role of mines in Romania and the Danube and the port of Odessa as well. Also, whether by the Ukrainians or by the Russians, both sides are using these mines. So this threat, where the French Navy in particular has always invested a great deal because we have a lot of expertise in that area, and the French Navy has been involved in a program where, for example, at Thales, we have delivered 2 dronized anti-mine defense systems, because this is a difficult threat. It's rather diffuse. It's very difficult to detect, especially when they are floating mines. This has reappeared in this conflict as well. And then the last point is, as you've seen, all of these drone warfare, whether it's air warfare or surface drones that have attacked ports, or underwater drones, because we've seen some of those in this conflict as well. So very interesting. So quite a broad range of different drones and different new weapons which we hadn't really heard about for a long time. So should we invest or not in this? In terms of defense, perhaps we should look at how we counter this. To counter the UAVs, the airborne drones, unmanned airborne vehicles. This is moving forward very quickly at the moment. We're investing a great deal in this area at the moment, and in different domains. At Thales, we're working on frequency jamming. We know the drones are usually quite well protected against that. Then there's also the directed energy weapons, which target electronic boards, whether it's boards that are used for navigation or detection inside the drones. Then directed energy, electromagnetic directed energy systems. And we have lasers as well, which can apply a hot point to disrupt the enemy. Then we have, with Nexter, we have the rapid fire cannons with a very high frequency of operation, which make it possible to deal with the drone swarms. Then we have a bit of AI, because to deal with the drone swarms is very difficult. There are a lot of different objects. You have to know whether you've attacked them or not, whether you've reached them or not, and have to be able to apply the right kind of cannon to deal with these swarms. So in terms of close self-defense, we have invested a great deal in that specific area, in the anti-air warfare. In the missile part, we talked about anti-vessel missiles. We've made a lot of investment in the electronic warfare. I'm giving some examples from Thales because I work for Thales, so I think it's probably interesting for you to hear about concrete cases. I'm not here to sell anything. I'm just here to talk to you about what we're doing and illustrating that with some examples. So concerning anti-vessel missiles, at Thales we've started our first complete digital revolution of these electronic warfare systems, because electronic warfare represents terabytes of data arriving. So this is, they use a very large frequency range and they produce a lot of data. So we had to work in a different way to deal with these data, bearing in mind that we're talking about, we always have a human operator who is involved. So this means they are decision makers. So we've changed our engineering approach in order to deal with this problem. And so we now provide decision support using AI to enable the operators to process these data, so that we present them with data which are quite sophisticated with a high added value, so that they're able to take the decision. So this concerns the intermediate defense frigates, which will be released in the next few years. So electronic warfare systems are completely new, making it possible to react to these missiles. And I would say that we carried out a test last year of these new electronic warfare systems on our aircraft carriers, which, and as a result, we received a prize from the French Navy as a result, because we showed that we were capable, thanks to very new algorithms, of detecting a whole series of things which we hadn't been able to do before. In particular, we showed that we were capable of linking tracks in the radar, which are very agile in terms of frequency. So they're very difficult to classify and to characterize. And we showed that we're able to monitor these, because we might get the impression these are different radar systems, whereas in fact they're not. So this is electronic warfare. Then we have the hypersonic missiles. In my opinion, we're not working enough on hypersonic missiles. We've started some work in the area of space and land with the large-scale radar. We need to see how we consider this in terms of naval warfare. This hasn't really been completely clarified yet. I'm sure my colleagues may have an opinion about that. And then concerning mines, I've mentioned that earlier. What I can say about the mine warfare systems that we're supplying to the French and British navies is that this is a complete revolution, because this removes the vessels away from the area of mines. And so these are systems of systems, in fact, because we're talking about managing several hundred surface drones, underwater drones, and airborne drones as well. Because underwater drones, we've already talked about that this morning, it has to be very autonomous. The surface drone doesn't need to be so autonomous, and the airborne drone has to be controlled because it moves very quickly, and so we have to be able to control that remotely. So it's revolutionary in terms of the way we're controlling our drones and the way we transfer data to the land, because the data isn't transferred on the vessels. They are going to gain in autonomy. Again, there are a number of phases that will be taking place over the next few years to make them more and more autonomous. We are gaining in speed in order to clear mines from a particular area, so this is an important criteria. And we're also gaining enormously in terms of the precision and the mapping of the seabed, so that we can see what is on the seabed. So that's very important, because there was a major conference yesterday about the detection of on seabeds and protection of infrastructure. The capacity we have to see what is underwater very specifically is extremely valuable. So I would say that we've invested a great deal in this defensive part, defensive weapons. For the navies, it gives them freedom of action in these areas. They can approach coasts, and they're able to work in the Arab and Persian Gulf in areas which are very enclosed, and can be, we have to have very rapid reaction times, and we're not necessarily therefore in the open seas, in fact. So concerning offensive weapons, I would say that we are continuing to invest in here. I would like to say more in terms of the precision, the impact of weapons that are quite long range. If we're looking at torpedoes, we're looking at the self-directing systems. We have torpedoes that are arriving on the Soufras, which are torpedoes which can be in the water for almost an hour. So they can be re-steered, they can identify targets, they can navigate within marine space. So the approach is completely different from the previous generation of torpedoes. What has changed in these weapons is the environment in which they operate. They operate in, Xavier talked about high-intensity warfare earlier. They operate in environments that are complex. Concerning the electromagnetic aspect, the spectrum is very loaded, very densely loaded because of the use of radars in communication. The spectrums are being, frequency spectrums are becoming used more and more, and very, very busy. And there were radars that emit at any time on different frequencies, and this can be a problem for the torpedoes because we carry out tests on the drones so that we're able to deal with the electromagnetic interference from these emitters. And so we are working a great deal on that aspect. And it's really a question of the environment that has changed a great deal and has become much more complex. And in addition to this electromagnetic spectrum, which is very, very full, we have the cyber aspect that has to be taken into account, and also the jamming, which is being developed more and more in this spectrum as well. So the consequence of that is that we have to be able to supply information that is reliable. And you can see there's a lot of information at the moment on the communication networks and in the media today, that we have the same problem in the combat system. So we have to provide reliable information that has to be provided more and more quickly, because to work quickly, you have to have the information quickly, to be able to take decisions quickly, and then you have to find the right sources of information. And I would say previously everything was centralized on a vessel, but once you have a naval force that is working between several vessels at the same time with a lot of different sensors being used, it's very interesting to be able to look at which sensor can give the best information at the best time. We talked about hypersonic missiles earlier. In the different phases of flight of these missiles, it's not the same sensors that are going to be detecting. It might be infrared, it might be radar. So all of these sensors have to cooperate together, and that's when we get to a situation, as we said yesterday, where we have you have to have the capacity to have collaboration. When I say collaboration, I mean getting information from one sensor and then mixing it with information from another sensor to be able to have either continuous detection or detection and classification after that, to be able to also then involve the weapon systems once you have the right classification and the right decisions have been made. And for example, we are working on the FCAS aspect, the next generation of fighters. In particular, we have developed the cloud technology. We've developed all the collaborative warfare aspect, and we've also done that in the naval, the sea area, and also on land, where everything in Scorpion and Titan, which are connected systems. And then when we show the stuff on these platforms, how to instantaneously acquire superiority by getting the right information in order to be able to accomplish the mission. So I would say we're not a question of complete superiority, which the naval forces had in their minds a few years ago. Now we're talking about obtaining very local superiority for a local action. This means we're working on the data in a loop. So this is very new. And finally, between the offensive and defensive weapons of adversaries, the border between those two is not very clear. When we talk about loitering munitions, for example, between the time when it's a threat and when it's not a threat, our customers say to us, what do we do? Because if the munition is loitering, it's not necessarily very offensive, but then it can become closer. And so there's a difference between the two. It is not always obvious. For example, compared to what we saw before, previously you have a missile arriving at Mach 2 towards a vessel. At that level, once you've detected it, the classification is fairly easy. Today, detection and classification and decision is much more complicated. Finally, when we're talking about the chains for detecting the weapon systems, we are confronted at the same time by the need to detect at a shorter distance, because the drones can often detect over very short distances. You need to be able to detect over longer distances. For hypersonic missiles, for example, we have increased the area over which we can detect these hypersonic missiles. We have to detect very small objects, very stealthy objects. We have to detect things that move very slowly and very quickly, and we have to be able to detect at a very great height and right down to the seabed. So the domain is expanding all of the time, which makes things more difficult. So the choice is to be made about the technologies we're going to develop and how we're going to develop them. So I would say in terms of offensive weapons, we are working on that. For defensive weapons, we're working a great deal as well, but some of the sectors occasionally have been slightly abandoned. And that's where we feel that greater focus needs to be placed in terms of research and investment. Thank you very much, Xavier, for those words. It's important to work on the defensive aspect. You have to work on the offensive aspect. The two go together. And finally, I'd also like to note another thing from what you said. One of the centers of gravity of our discussion is the importance of information, its nature, how we process it. This has come up in many of the examples you've given. Yannick Thomas, I'll hand over to you now as you give us your point of view, which also highlights new technologies for hypersonic technologies. Yes, Hervé was talking about from the deepest to the highest. I would like to focus more on on the ballistic aspect, outside the atmosphere, and also the airborne aspect. As you mentioned in your introduction, the war in Ukraine has fundamentally changed our perception of how we defend our territories. First of all, because war now is on our doorstep, and also because we've seen the emergence of new weapons. These weapons forced us to rethink our defense strategy. This issue was covered on the political level at a conference on European airborne weapons with President Macron at the Paris Air Show. President Macron asked the question about the balance between offensive and defensive weapons. On the industrial side, this led us to ask ourselves questions and to rethink our approach to be able to respond to the technological needs and also the financial aspects. I'll come back to that later. Financial aspects are very important when talking about these new threats. So, my presentation will have 4 parts. First of all, a reminder of the threats that exist today, because the threats are still here and we have to combat them, and they have the means of defense that are put in place to counter these. Then I'll focus on the new threats that have emerged in Ukraine. And then we'll talk about the hypersonic threats and the impact this will have on defense, because there are changes that need to be put in place in our defense systems. Then after that, I'll try to talk about how the balance between offensive and defensive weapons can meet these new requirements and these new threats. And finally, I'll give a broad view of the offensive weapons that we are trying to implement and which will enable us to meet this need for balance.
Suivant. Pas l'air de passer.
I'll move on to my next slide, if the remote control will allow me. So first of all, the threats we faced yesterday and those we're facing today, those which are threatening our territory, the ballistic aerial threats, of course. When you're defending a territory, creating a bubble, when you're fighting against air ballistics, that's very, very complex. It needs a whole range of different strategies and resources. You will often hear talk of IND, Integrated Air and Sea Defense, which is designed to defend the whole theater against air attacks and ballistic missiles. So what is the ballistic battle? Well, it's all of these missiles which are short or medium range. These missiles can be more or less complex. There are different types of power. They can their heads can be concealed to full defense systems. And these defensive systems that Hervé was talking about a little bit earlier on are very complex, and they include a whole range of capacities. In these capacities, we have satellite systems which can detect early on. These are satellite systems that are equipped with infrared sensors, And that means that the aggressor can be identified, and it means that the impact zone of a missile can be determined very, very early on. In these complex systems, there are also radars. These radars will fine-tune the trajectory of the missile and to identify the best interception methods. That will be intercepting missiles, which are quite similar to the threat, the missile which is causing a threat. They go very, very quickly, and they can blow them up. So on top of these systems, we can also use terminal systems, which are similar to those that you will find defending zones, and these A to AD zones in the final zone. But there is very, very little time to be able to intercede those anti-access, anti-denial bubbles. So we've got this zone defense, which is possible thanks to these terminal systems, which can intercept ballistic missiles that are short range or cruise missiles. It really is important to note that creating these anti-access, anti-denial bubbles are a continuous process. Resources are being enhanced the whole time. Offensive means are evolving, so defensive means have to evolve also. And these strategies, these defense mechanisms have to evolve to keep in step with the attack, which is constantly evolving. Let's move on to the next slide. Over recent years, we've seen the appearance of new threats, a new category of missile with unique characteristics. They're hypersonic missiles. Hervé touched on them briefly. Let me give you a reminder of what one of these is. A hypersonic missile is a missile that reaches speeds which are over Mach 5. If you're not in the air sector, Mach 5 is 1.7 kilometers per second. So they're very fast missiles. And on top of that, they are very easy to maneuver. What you can see here on the picture at the top right, that is comparing a ballistic missile with a hypersonic one. The hypersonic missile's trajectory is similar at the beginning to the original type of missile, but once it's been launched, when we know where that ballistic missile is going to fall, then the hypersonic missile it's got that kind of purple lily shape that you can see there on the screen, and that zone is incomparable with the impact zone of the ballistic missile. So given these new threats, and I'll tell you how later on, well, this is the type of ballistic missile. In this category, there are several types of hypersonic missile. There are ballistic missiles with a head which can be maneuvered. In the final phase, it can carry out maneuvers which make it harder to intercept in the final phase. There are hypersonic cruise missiles also. These are the HIMs, hypersonic cruise missiles. Whereas today we have cruise missiles that travel at the speed of an aircraft. Well, today there are missiles that are equipped with the different reactors that can reach speeds that are much higher than Mach 5. And the final category of hypersonic missile are these gliders. If you read up on them, you'll see these HGVs, hypersonic glide vehicles. These are systems that are carried by a ballistic missile. Once it reaches in its atmospheric phase, it is released, it is launched. Instead of going down on its target, it is able to bounce and be maneuvered, as you can see in the pictures on the screen. So these threats have been on the horizon for some time. Yet the United States have been trialing them. At Chinese military parades, we see examples of these missiles. North Korea has also carried out a test. of hypersonic missiles. But up until now, these have simply been trials. However, with the Ukraine war, we have seen the first operational firing of these hypersonic missiles launched from aircraft. So you might have heard of the Kinzhal missiles. They are the ones that typically have been fired in the Ukraine. So these threats, which are considered futuristic threats, have now become the threats of today and the very immediate future. So why are these missiles such a problem? Well, if we compare them with ballistic defense that we've always known, we're still going to have satellite detection. So we're going to have infrared sensors on satellites which will still be able to detect one of these missiles when it's launched. However, in the example of the glider, once the propulsion has ceased, we will not know any longer where it's going to head because it can be maneuvered and its point of impact will change thanks to maneuvers carried out during the flight. These hypersonic missiles fly at altitudes that cannot be intercepted by an atmospheric interceptor or an endoatmospheric interceptor. The altitudes range between 30 and 50 kilometers. And so, as things stand today, a ballistic interceptor can intercede in the exophase above 100 kilometers, and air defense missiles that exist today reach altitudes of 20 kilometers. So these hypersonic missiles are amazing examples of advanced offensive weapons with outstanding speeds, great maneuverability, which make it really hard to intercept them. The reaction time to intercept is greatly reduced. So, but let's not throw in the towel quite yet. We do have some defense systems that are already deployed, although they weren't really designed to cope with these new threats. And there are new initiatives that are on the table to withstand this type of threat. Europe is protected by the NATO shield, which is the EPA architecture deployed by the United States in Europe. And it's made up of satellites that detect missile launches, radars that monitor the missiles as they advance, and we have interception methodologies which are deployed in Europe, in Romania, and in Poland today, plus frigates which are positioned in the Baltic Sea, Mediterranean, or the Atlantic, in order to intercept the ballistic threats. As things stand, we haven't had a case of a hypersonic missile, and given the height of those missiles, it would be extremely difficult for the defense in place to actually deal with it. Today, there are initiatives that are being taken within Europe. There's one called Twister. There are two parts to Twister. The first part is Advanced Alert, Space Alert, and we are trying to construct a project of constellations, several satellites therefore, that will be able to detect these missiles earlier in order to intercept them. And there's another project to develop an interceptor that can intercept a hypersonic missile in the higher levels of the atmosphere. So there are those two programs which do exist, or two studies, if you like, in Europe. One of them is spearheaded by MBDA, and we are participating in that. That's for one interceptor that could counter hypersonic attacks. And then in Europe, in a more or less coordinated manner, Germany, in light of the launch of the Kinzhal missiles in the Ukraine, has taken the initiative to construct a European defense system. It's a European Sky Shield. Germany has brought together 18 countries to work with it on that project, as you can see on the map on the screen there. Germany hopes to deploy a system that is based on multi-layered defense, based on different systems that the Germans are developing, or that they will buy from the Americans, such as the Patriot system, which has already intercepted Kinzhal missiles in the Ukraine. And there's also going to be a higher level based on exo-atmospheric missiles manufactured by Israel. So Germany has noted that as things stand today, we do not have the resources at our disposal. So Germany has chosen to go and purchase things outside of Europe. So these are the initiatives that are underway in Europe today. When we talk about defense, we realize that there are limits. Defense is so essential, it always will be, but we must realize today that there are limits in our defense. In terms of these limits, let's say that the offensive policy has advantages. When you're firing, you know where, when, and how you're going to be launching your missiles. All system equations are known in the offensive party, whereas the defending party does not know any of that information, has to constantly adapt to the movement of these offensive systems. And from what we've seen, for an interceptor of a hypersonic missile to be effective, it has to have maneuverability capacities that are 3 times higher than those of the threat. And to reach these performance levels, the defensive system will cost much more money. You have to invest a lot more money in defense to ensure a watertight system. But it will never be totally watertight. Adding to that, there are strategies of saturation, whereby the offensive team fires a whole load of missiles to saturate the defense system, then the defense system just doesn't know which way to look. So one can imagine that the offensive strategy imposes the gameplay on the defense. So I've got 2 examples up here on the slide. We've got some recent examples which convince us that defense strategies are limited. The first one is in Ukraine. Earlier on, I was talking about those Patriot systems that were used to intercept Kinzhal missiles, which are hypersonic. That was very satisfactory. These missiles intercepted those Kinzhals, and there's a small picture there of a missile which is in the grass. We found loads of them in parks in Kiev. They hadn't exploded and they hadn't been destroyed because, given the balance of power there, I think we have to you have to launch 20 interceptors to destroy 1 Kinzhal missile. So this is feedback from the field in the West. If you look at the Soviet press, they say it takes 30 Patriots to destroy 1 of their Kinzhal missiles. So we really do have to invest. And when we note that in financial terms, the cost of a Kinzhal today is about 1 or 2 million, and a Patriot is between 3 and 4 million. Well, I'll leave you to do the maths. And if you know that your defense missile is going to cost twice as much as the offensive missile. A second example, which I've put up here on the screen, is an article which was published on the 23rd of May in the Chinese press. And it kind of caused a bit of a ripple of fear in the armed forces staff. It's an anti-ballistic missile, which was, in familiar terms, was known as the aircraft carrier killer. It's very maneuverable in its final phase, and it's sufficiently precise to strike an aircraft carrier. And this Chinese article tells about simulations which were carried out by the North University of China, demonstrating that with 24 hypersonic missiles, the Chinese army can destroy, and they've used their algorithms 20 or more times, and each time they found the result that they could destroy a whole group of aeronaval attackers, aircraft carriers on the China Sea. And systematically, they would destroy at least 5 of the 6 vessels in that fleet, with that fleet of ships and vessels. The aircraft carrier was systematically destroyed every time they ran their algorithms. So once we've noted these limits, we realize that we have to take a look at targeted counter-offensive strategies, because it will be cheaper than defense, and how counter-offensive strategies can make up for your defensive shortcomings. All right, I don't have much time. I'm going to have to speed up here. Let's move on to the next slide. Okay, in terms of offense, this is not new to France. France, for a very long time, has been taken an offensive stance and uses high-performance equipment. We've got the M51, developed by Ariane Group, which was launched from French submarines, their missile launchers. And when the Ukraine war kicked off, we launched 3 DSNLs, and France was able to support a stance against Russia. And another dissuasion element in the French nuclear armory is airborne dissuasion, developed by MBDA, and the future SMGK, which has been developed by the same company and which is sold by the Ariane Group. Moving on to the next slide. There are initiatives in France in the field of hypersonics. Last year, France joined that very privileged circle of nations which have the ability to do deep strikes thanks to hypersonic missiles. At the end of June, the DGA launched a hypersonic glider, and that has caused a lot of fantasies to be rife on the social networks. There were pictures of spaghetti in the sky. That wasn't a missile that got lost over Biscarrosse. This was the first hypersonic demonstrator developed by Ariane Group. And it fulfilled its mission 100%, and that gave rise to further tests, further demonstrations, before, we hope, operational capacity for France. So offensive resources are there to have deep strikes, and in terms of offensive strategies, we have other resources that can be used during operations. We have developed a network of sensors which enable us to catalog all of the space satellites. Why do we need to catalog them? Well, before you make any attack, the attacking country needs to know what the situation is on the ground and uses observation resources to do so. And these are resources that can also be used to redirect offensive resources during a hypersonic missile flight. So we need to know where the opponent's satellites are, or the enemy satellites are, and we've got laser resources which enable us to blind observation satellites. That means that we can hide information from our enemy, but we can also hide targets, because these resources are also used to define targets for offensive weapons. So there are 2 strategies for deep strikes and lasers. So I'll just wrap up here by saying that creating these defense bubbles is a continuous challenge. We see that offensive resources are evolving constantly. We have to do the same, therefore, for our defense. But that's not enough. We've already got dissuasion, which is an offensive strategy, and it can defend vital assets and install doubt in the mind of the aggressor. But here we have to find that balance between defense and offense. Cheaper than defense is counter-offense, and if it's well controlled, and when we were at the Mediterranean Symposium, we saw some European initiatives which have been launched. We can't all use them all. We're going to have partnerships around the Mediterranean to construct the defense and the attack of the future. We need our partners. Thank you very much. Thank you very much for that very full landscape. And now we are going to hand the floor to Laurent Duport, who is going to add further details. Well, good morning, ladies and gentlemen. Thank you very much for being here. I'm full of admiration of my colleagues, because they seem to have found the beginning to an answer to this question, or a definition at least. I've got a slide here. It was very difficult for me to work on this question. This is a subject which is very technical. Offensive, defensive technologies. It's not my comfort zone, so I've just clung on to what I know best, which are missiles. And I've taken an example. This is an example we're really proud of at MBDA, Meteor, and it's the best in its category. Is it offensive or is it defensive? Well, I will come back to the very end, but if you can help me find the answer, I'd be very grateful. But to win a battle, it's better if you launch before your enemy does, and you need to have a missile that goes far. And if you are firing after the enemy, then it's going to be defense. So I'll come back to the end, back to that at the end of my presentation. But there are three levels. There's technology, of course. There are some technologies which can only be used as offensive or defensive, but there are others which are for both. We've got products, we've got missiles. Some are clearly offensive or defensive, some are in the middle. It depends on the intention and how we are using them. And I think that you can use them for both. Let's move on to the next slide. Here is a catalogue of MBDA missiles. This is our product catalogue. On the left, you've got all of these deep strike missiles. They're very offensive. I suppose they could be counter-offensive as well. So I don't know where we're going to put those along the spectrum. On the right, we've got anti-air defense, zone defense, self-protection on a closer scale. So that's part of defense. So we can call those defensive tools. Then in the middle, we've got air combat. And it's not clear-cut whether it's offensive or defensive. And we've got land combat as well, which is more or less the same as air combat. It depends what your intention is, and it depends on how you're using these missiles. So it's a difficult question. It's the same when you're working, trying to shoot vessels and destroy vessels, etc. I have not talked about dissuasion. I'm having a hard enough time defining what's offensive and what's defensive. Dissuasion is an attack, but the mindset is defensive because you're defending your home territory. So it's very ambiguous when you're talking about dissuasion. So to try and give you some food for thought, rather than an answer to this question, I am going to try and show you two slides here about what typifies the definition of a system when your intention is to be offensive or when you hope to be defensive. So a first question, which has been coined, when you're talking about offense, is these weapons that are developed to combat guerrilla warfare or terrorism. That's been the case for the past 30 years. In these defense operations against terrorism, we have mainly been using offensive weapons. We've a lot of strikes. So it was an offensive stance. It was an asymmetrical combat in external operations. So here, in fact, we've used a lot of offensive weapons, only few defensive weapons. And we put to one side that question of self-defense because there was no threat from the sky, for example, or very little threat from the sky. So I'm saying the exact opposite of what has already been said here this morning, or what was said in the question, in fact. But now we're talking about high-intensity combat, and the question comes, of course, from this war that we're seeing in the Ukraine. Do we consider that offensive has overtaken defensive strategy when we see what the Russians are up to, and counteroffensive strategies by Ukraine? We see how very hard it is to cope with defense. Yes, there's a lot of finance involved, but the Ukrainian counteroffensive is very, very difficult. There is a culture of defense in Russia. Recently at the military school, there was a presentation on Russian defense strategies with that culture of defense. And we see over a 30-kilometer band, 3 layers of Russian defense to protect the land which they have won. So I would say initially that, well, I think today defensive strategies are more preponderant in those countries, and where the situation is kind of more or less the same, despite hypersonic missiles which have appeared. Putin created a bit of a buzz a few weeks ago talking about his hypersonic missiles, but we've seen how they've been used initially, and there have been no real military impacts. Nothing decisive. It hasn't really changed the landscape. And I want to talk to you also about the challenges and the advantages and the disadvantages of both offense and defense strategies. Whatever system you're building, whether you're calling it an offensive or defensive system, the important thing is if you're being offensive, you will always have the advantage of deciding when you are going to strike. And that is a huge advantage. You can create a surprise, you can plan, you have time to plan, and you can use that strength, that strong position. You choose your target. But when you're defending, you have to defend all of your targets. When you're attacking, you say, I'm going to pick that particular target. And so there's an imbalance there. As Unique has already mentioned, yes, you need more defense resources if you hope to defend from even just a single attack. Conditions now, when you are defending, you have to depend night and day. If you don't have a lot of resources, then you would imagine that you're going to carry out your attack during the day when the weather is fine. It would cost less, and so defense-wise, you would try to protect yourself in those particular conditions. As for the trajectory, well, that's the great advantage of the hypersonic missiles, because you can choose a zone, you can choose an altitude where there are no defense mechanisms. So there's that 20-30 kilometer band where there is no defense, so you can position yourself there. And it's a complicated question when you're thinking about a military system, but let's talk about combining effects in a multi-level setting. So the challenge is, well, you have to have good intelligence to break through the defense. Speed can be a plus. Maneuverability is also a plus. I'd come back on to the subject of saturation. We see a lot of these drones which don't cost a lot of money or very cheap ammunitions. And the sensitivity will vary from one player to the next, with collateral issues, which are very, very important to us.
Concerning defensive weapons, it's a question of permanent posture. You don't know when your adversary is going to attack, and so is the question of being constantly ready 24 hours a day. This is a question of the environment. The coverage has to be complete. You have to have intelligence to be able to anticipate the strike. There are 2 levels. There's also the design of the defensive system to be able to provide information to be familiar with the threat. I'll come back to that later. It's important to know the threat to be able to define as best as possible the defensive system. You need to mustn't underspecify or overspecify. In the first case, it'll be probably far too expensive. In the second case, it'll be inefficient. So there's a question of relevance of definition. Then 360-degree, we've seen with the sector-based Patriots, 120-degree coverage. We haven't made that choice in France with the Santé system that we're co-developing with Thales, and this is fortunate because we need to have a 360-degree defense because we don't know where the attack is going to come from. The example was given of the American IPA defensive against ballistic missiles. There are ground radar systems, the LD offshore, which is the American system, which are directed towards Iran. This is a concrete, it's a physical installation. Whenever there's a change in the direction of attack, we're talking about the Kinzel, which are launched from aircraft, if the threat can come from anywhere. So these defense systems, which were designed with a specific direction in mind, are limited when you're faced with these kinds of attacks. The question of time, of course. Everything that happens today uses time, reaction time that is imposed on the defender. The contraction of time, if a hypersonic missile, the reaction time is shorter. The maneuvering is a question of time as well. You have to have the lily pad that you've seen. You don't know where it's going to go. You have to warn half of Europe to say that they might have to intervene against a threat. The question of complexity is true with the drones. We're talking about extremes. It's a very, very sophisticated and high performance. When we talk about a hypersonic missile, it's the same thing with a drone. Drones introduce a very high level of complexity for a defense operator who will have to have a high performance defense system to deal with a fairly basic offensive weapon. These are the tasks we have to deal with when you're playing at home. We know what we have to protect. At MBDA, we have to be self-critical. We often think about, we think we're attacked by a missile, we might respond with a missile. Of course, the defensive sphere is much greater than this active terminal defensive system. You can have jamming and lures that can be used as well. Can we move on to the next slide, please? I'll try to answer the second part of the problem, which was raised, which was the hyper speed, the cyber. Is there still room for the A2DAD bubbles? This has been very well answered by Yannick. I won't go into more detail there. Here we have to be very clear, a hypersonic missile, whether it's defensive or not, and then we have to be able to put in place the right defensive systems against these hypersonic missiles, with an imbalance on the terms of the cost of the number of missiles that have to be fired to defend against an attack missile. In the naval area, if you're on an aircraft carrier, it has to be protected. And so you have to have defensive systems on the aircraft carrier, whatever happens. Then we have lasers. Today, their main application is anti-drone, because this is the most accessible solution with an economic issue, because you don't want to use munitions that are too expensive against a drone. The laser is costs €1 for each shot. So it's not, lasers are not used for offensive reasons, it's really used for defensive purposes. Maybe in the future that will change, but at the moment lasers are used only for defensive operations. And they have cyber actions, cyber defense, cyber offense, you're familiar with that. There's no very cut and dried answer about the advantages of one technology rather than another. In terms of technology, hypersonic technology has been developed by UNIC. Then we have to use speed, maneuverability, the altitude at which we can operate, and the launch points. Instead of you using ballistic missiles fired from a point on land, you can move on to firing from aircraft or vessels in order to get around the defensive systems of the adversary in that way. Then you have a certain level, this increases the uncertainty, and as the response time is a main lever to put in place this invulnerability that Putin mentioned at one time. That's not really the case, in fact. Then we have the saturation techniques. This introduces complexity. A drone swarm is a very complex system to deal with, where the behaviors are very complex. Yesterday, we had the conference on AI and the collaborative warfare, and we are a player in developing, rather than developing missiles, we are depending on the intrinsic performance of one missile, we're talking about a swarm of missiles. And we use the word, we're talking about a quantity which is about 12 or dozen or so missiles. It's like a pack of wolves. We can talk about a pack of missiles. We have to talk about a pack of missiles that collaborate together. This makes it possible to have an object that doesn't cost so much individually, but provides the performance we need, because we can use this concept of a pack of missiles, or rather than a swarm of drones. For you were talking about a ratio of 2 between a hypersonic missile and the symmetry, the asymmetry that is imposed on the defense system. So a lot of zeros involved when you're firing Patriot missiles against a drone, which can happen. There's a complete imbalance in terms of financial requirements. This financial aspect has to be taken into account when you're talking about offensive weapons. In terms of defensive weapons, we've talked about defending against hypersonic missiles and the question of automation. And not talking about autonomy, but talking about automatic response systems. We've had those for many years. The Thales systems in America have had these systems for many years, and they are fired automatically in response to an attack, because you don't have to have time to have a human operator respond. It's very risky. When you know very well that we're being targeted and the threat is a missile, it's not an Airbus, it's quite easy to characterize the behavior of a missile with automatic response systems in that case, and it's quite a good way of saving time. Then the anti-drone action, we haven't talked much about that. We are all working very actively in that area, whether it's Thales or MBDA, in the anti-drone area. There's an economic factor involved here, because these objects are not very sophisticated, but there's an economic financial issue about how we deal with that. Of course, the war in Ukraine is a very good observatory of what is happening, and the resistance against jamming and all of the techniques that are put in place to navigate without a GPS, and the collaborative warfare. Coming back to the AI conference, it was a very, very interesting conference and very relevant. Today, if we're talking about the C3 drones launched by Russia, there's a machine for processing this from America, NVIDIA, which is built to have AI. It's built to use AI. Today we have a few questions. Are we going to use that or not? I think Russians in Ukraine have gone past that kind of question. AI in drones is already the case. And there's a fact there's a certain autonomy in these drones who will be able to process images. So I have this issue of having to deal with systems that have gained in autonomy and are less limited by the need to link up between the drone and the operator. This is one way of dealing with the drones, is to jam the link between the two. In France, what we call the loitering munitions, what we also call remote operated munitions. We're working on a demonstrator for that. In other words, you still have an operator involved in any case. So in a way, this is a kind of vulnerability. We can secure and defend the link as much as possible, but the Russians have gone beyond that stage. We have systems for developing stealth munitions and stealth drones, and we shall make it possible to carry out low-cost interception actions. Then my last slide, or the penultimate slide. Of course, I've already haven't answered the question completely. It's more complete than that, because more complicated than that rather. We have to talk about the multi-field sphere. Here I give a quote of the results from Orion. This campaign of test was carried out for multi-environment or multi-field environments. The aim is to produce synchronized effects by using different levers. I've taken the example of jamming, which is at the same time a way, for example, of protecting against drones in the anti-drone combat, but also a way of accompanying strikes in what we call our collaborative weapons, working in a pack. Of course, it would be a shame not to have some parts of the pack to have some jamming and electronic warfare components. We're going to develop that, whether for offensive or defensive weapons. Space has been mentioned rapidly by Unique. Here again, there's been a change and an increasing awareness that the nasty things are going to happen in the area of space. We developed a lot of capacities benefiting from the space, but require a number of space resources. We've seen what's happening in Ukraine in the space. Well, we've also seen that we need to protect our space assets. And I mentioned the Asterix exercise because for the first time we started to see how we could carry out actions in space, apart from the actions and the programs that exist already, to enable us to have a good knowledge of what is happening up there, and also to be able to take action in space. So finally, for my last slide, thank you. We've talked about launching shield and the opposition between the sword and the shield. Of course, this competition between the two is something that is constantly happening. The progress is made in both areas. One catches up with another. This is going to be the case forever. I can't tell you whether there's really been a real progression in the offensive weapons or defensive weapons. I don't really know. What certainly is the case, and I'll end with this, is that we have to know what the threat is if we want to be able to defend ourselves, and vice versa. We have to know what the defenses are of our adversary to be able to properly design our offensive weapons. We're able to do this at MBDA. We do both in our portfolio. We have both. This enables us to have a good knowledge of the technology, the maturity of the technologies, and we have a huge investment in the feedback and from our adversary systems with a lot of experts who are involved to try to analyze and understand as best as possible the equipment that our adversaries have and to anticipate what direction they're going to go in. And so we shouldn't only look at the present situation, we have to anticipate what will happen in the future and how our adversaries will develop their systems. Thank you very much for that presentation. We'll now take some questions, of course, from our audience. What strikes me is that you have this opposition between the sword and the shield. What I take away from your three presentations is the variability of offensive weapons has increased. It's no longer just a sword. There are three main areas I think we can identify where we have gained is the form of the threat. You said, Laurent, it ranges from a very expensive missile to a very cheap drone. Is the trajectory of the threat, of the kinetics. The example of the hypersonic missiles for me makes this very clear, and also the possible autonomy of these systems. We talked about AI. You say at this stage it's more a question of automation. We're starting to see things that are automatic reflex systems, and these systems are going to learn more and more. If you combine these three, the form, the trajectory, and the autonomy, we can see that the uncertainties have increased considerably compared to the previous system of the same problem we had 2 or 3 centuries ago or 1,000 years ago. So this is very new, and so no doubt the relationship between this variability of the threat and its unpredictability is increasing, and the threat of the defensive systems to anticipate that this becomes increasingly difficult. This is what I take away from your presentations. You can react to what I've just said, of course, if you like, but I think nevertheless that our work is going to become increasingly difficult. We'll take some questions now, of course. Let me just see what your questions. So what lessons do we learn from the conflict in Ukraine in terms of its spatial aspect, whether it's for its own capacities that we need to develop or the types of threats? I'll be happy to give an initial answer to this one. Well, we can see the importance of space in terms of communication specifically. Not only that, but communication is a very important part for the role that space plays in the Ukraine war. We can see this issue of dependence on a private company such as Starlink, which can decide one day perhaps to stop providing its service temporarily. After that, what we have to the important point here is the low orbit systems. In the dual application systems, where we're talking about civilian means that are used for military purposes, but with dual systems, for me, this is the key. There's no real military business model for constellations because it's not just enough to launch 100. You have to launch thousands, and you have to keep doing it. If you don't have a business model to do this, it's not going to work. So I very much believe in these dual capacities. Doesn't mean they shouldn't be designed from the start for a military purpose, whether it's national or European, I don't know, but this is always a question of resources. And then another important part that Unique mentioned is the detection of ballistic missiles. Today, we're not really capable of providing this defense against hypersonic missiles without a space component. Not just for early warning, as was the case for ballistic missiles, because for ballistic missiles, once we had detected their launch and their means of propulsion, we knew where they were going to land. You've seen with the maneuverability of hypersonic missiles, you have to follow them. You have to pursue them. Radars will help us with that, but there is a certain radar horizon, and so space will play a very important role to deal with these hypersonic missiles. This is the role in Twister of space. So we have these two dimensions, which I think are very important. I'd just like to add something else. Laurent was talking about Twister. There's a lot of coherence in France in French defense industry. We are all three of us partners in this, whether it's Thales, MBDA, or the naval group, to improve these capacities. Today, this can only be done on a European level for budgetary reasons, I would say, but behind that, we do maintain a certain sovereignty because France has a knowledge which it has acquired over many years in this field of space detection. So we're trying to keep a certain sovereignty in that area. I'd just like to come back to the experience we have in Ukraine on the offensive weapons that we need to have against space assets. I talked about the laser, which can deny information and intelligence and deny guidance of systems. We are seeking to set this up in France. We hope that this capacity will be clearly identified. The Russians have clearly identified it. Here we're talking about Ukraine at the moment. If we go back 10 years or so, in Crimea, it was clearly shown that the Russians have dazzled observation satellites to be able to carry out operations on land. If we don't want to remain lagging behind in terms of our offensive capacity, rather than defensive, we also have to make sure we make progress in that area as well. Of course, sovereignty is fundamental. We have the Syracuse satellite, for example, in France, which guarantees our sovereignty. That's important. Concerning communication, we've become very dependent on space because of its high bit rate. So the key word is diversification of connectivity, because we can have local connectivity at very high bandwidth, and this enables us to have diversification, VHF, UHF, and NHF. And the French Navy is carrying out exercises where they cut satellite communications to be able to see how war will take place if we eliminate that dependency on space. That's very interesting. And what we are looking for in Thales is, in terms of communication, is resilience of communication. This is what we're doing with HF, which HF, which broadcasts on a very broad spectrum. These are cognitive communication. In other words, it looks at the condition of the spectrum, and we look at where we can transmit in the spectrum where it is available. And that enables us to increase resilience. That's very important to diversify the sources of communication, including very high rate laser communication. I'd just like to add about this race for data. As a missile manufacturer, we are looking for objects in a long way away in a hostile environment, so we also need to have as much data as we can. Yes, and concerning this question, one last point. There's a link between Ukraine and the space sphere. Of course, Musk had a role to play there with Starlink. In the US, for example, at the moment, well, if you look at what has happened after this episode, it wasn't after that episode. In fact, ever since 2017, before the Ukraine war, a lot of thinking was done about how to use commercial means in a conflict. And we have this special case of Elon Musk, who said Starlink won't be used to guide missiles because that's something else completely different. This is a case that was studied. So there's a whole question of jamming of, in the conduct of war, and war by proxy as well. So it's quite complicated. The second question, at the moment, are nuclear missiles already positioned in orbit? What does international law say in this area? This, of course, is banned. There is no, it is prohibited to use weapons of mass destruction in space. Have a fractional orbit bombing system, which is a system that we always talked about. The Chinese, it is being said, are thinking about this kind of aspect as possibility as well. It's all hypothetical in theory, but normally, as far as we know, there is no new nuclear bombs in space. Maybe you have something else to say about that. Another question is the transfer of manufacturing of engines for Ariane. Isn't that a strategic mistake? I don't really understand that question. You're talking about the transfer of manufacturing of engines. Concerning the strategic engines, on the contrary, 2017 we had bringing together of Safran and Ariane to be able to set up a group to be able to constrain all of the chain, to be able to make the engines and carry out the engineering, and to be able to build the initial stages. All of this strategic part was not was kept under control. And concerning the specific aspect of the tactical engines, part of that was subcontracted, but this is not linked at all to dissuasion. If you're talking about the hypersonic missiles, today we are producing demonstrators where we use external means to launch these demonstrators. That's true. We're also developing our own means of launching future hypersonic weapons. So, on the contrary, we haven't, we're not subcontracting or outsourcing any of that kind of aspect of manufacturing of engines. It's very interesting when you look at the industrial sharing. When France doesn't invest in a field because it has decided to do something else. In the industrial part, at Thales, we have some customers who want us to provide that kind of capacity, so we have to ally ourselves with other companies. We have to abandon part of what we were doing previously, and we have to share part of our expertise with other companies. It's not always easy to go backwards after that. It's a question of sovereignty, a question of satisfying customer requirements as well. At Ariane, there was some work with German companies where we saw that kind of thing happening. Very quickly, what is the role of less costly tools that are easier to use in Ukrainian defense? What is the role of tools that are easier to use and less expensive in Ukraine? So in other words, what are the tools that are the least expensive and which play an important role in Ukrainian defense? Are they drones, for example? We've had a lot of talk about drones. So today, what do you think? It's not very easy. What is the Ukrainian arsenal in that area? I'd just like to answer on one specific aspect. We were saying they need 30 missiles to bring down one hypersonic missile. You also have to take account of the the cost of the target that is being attacked. When the Ukrainians launched the Storm Shadows against a frigate that cost 300 million, and you don't have to answer with something which cost 3 million. You have to defend something. You're defending something which is worth 300 million. So you have to take the account of the cost of the target. So it's very important. We've seen trends where people say, let's abandon lots of things we're doing today and let's use the directed energy weapons. It doesn't cost very much. It can do whatever we like. And all we have to do is use the right frequency and we have the solution. That is not true. Directed energy systems can't do everything. They only can be used in specific conditions with specific electronic printed circuit boards. Well, it's true that the launch itself isn't very expensive. Let's take another question. The one at the bottom, I think, which will enable us to have clarification about the presentations that were given. There was a question that is there are no interceptors on the 30 to 50 kilometer segment. How do we manage to, in this case, destroy satellites that are in orbit at a much higher orbit? We're not talking about the same range at all. We're talking about a 30 or 50 kilometer altitude. These are the higher layers of the atmosphere where it's not possible to control an interceptor or a missile. It's more difficult in any case. In the lower layers of the atmosphere, it is possible to navigate. We are working to be able to solve this problem of the area between the two. It's a question of means. At higher altitudes, we use missiles which use solid or liquid fuels, which using mobile nozzles to be able to navigate. These are the kinds of missiles that are used to destroy satellites. These are anti-satellite weapons, but it's more or less the same thing as a ballistic missile interceptor. It's exactly the same thing. A satellite in orbit is above 100 kilometers. So above 100 kilometers, you can use the exo-atmospheric interceptors, as we call them. Yes, we're not talking about this 30 to 50 kilometer area where we are able to develop interceptors and we're able to, they are able to navigate. In space, so we have the example of the Chinese and also the Indians who haven't done anything better. There's one major disadvantage of using this kind of system, that it generates a huge amount of waste and debris. Our policy in this area, when you think about the impacts of space, is that we don't want to generate any debris. Otherwise, you're causing a problem for yourself. Technically, it's not very difficult. You're right. A lot of countries have the capacity to develop missiles that go above 100 kilometers, but it's not a very good idea, because you're going to cause problems for yourself. In fact, by doing that kind of thing, you're creating a lot of debris. One of the last questions we're going to take now is, this is something that has already been mentioned. What are the tactical means of defense against hypersonic missiles? Hypersonic missiles are something that people are very interested in. People want to know, does that mean there's no way of defending ourselves against these missiles? Because the trajectory can't be predicted, and does that mean we're in a situation today where it's very difficult to defend ourselves against hypersonic missiles? Do we have a beginning of an answer? Yes, it is complicated, but we are working on it. Hypersonic missiles were the missiles of tomorrow. We could see they were going to be introduced, and as Xavier said, we are working on systems and not on single or individual capacities. It's a combination of satellites, radar, interceptors. We are working on this combination typically for satellites, where up to now we're working in a great deal on geostationary satellites at 30,000 meters, where this made it possible to observe a complete area. We realized that when you observe a hypersonic missile that's going to fly at 35 kilometers, if a glider has a very reduced signature, to detect its infrared signature at that height will be very difficult. But now we can see with Starlink, this is in the civilian field, We are thinking about having the same solution in the military field to have much lower altitude satellites, which then will be capable of detecting these threats. And maybe Hervé could give us more information about this in terms of radar. Things are also being done to detect these threats too.
Merci. Donc...
Okay, my turn. I'm Hervé. Xavier. Okay, we're talking about radar detection. It will detect what we ask it to detect, says Xavier. So it will go out and seek for what we ask it to find, and so we adapt to that. So we're trialing currently to adapt our radars to the Mach 5 attacks. The physics of those waves change, because if you, depending on the field where you're emitting, the weapons are all going to be impacted by wind turbines, for example. It's the same for hypersonic missiles. So the second thing to take into account, so there's how do you detect it, first of all? And the second thing to take into account is, do we have sufficient warning to do so? So where are we going to be looking? How can we enhance the scope of our radars? We can do that on a one-off base, saying abandon these functions and focus on this, for example. So we do the calculations, we see how the radar is working with combat systems. That's what we're doing in the Netherlands with our business activities up there. And final point, concerning infrared. Yes, we do have ability. We can detect those missiles, but as you have seen, every now and then they have no fuel, no infrared. They end up as gliders. There are different phases, there are different components. So we're not completely naked in front of this phenomenon. But if you're asking the question, do we have complete systems in place, the answer has to be no. I'd just like to add a little bit to this to give you a glimmer of hope. We're talking about hypersonic missiles going above Mach 5, but they aren't over Mach 5 for the entire trajectory. It's difficult to direct it precisely at such speed, such height, when there's such heat, and penetrating through the atmospheric layers, which are thicker and thicker. So today we do have resources which won't do defense, zone defense, but do offer some kind of capacity. So we're not completely unprotected. So hypersonic, hyperspeed, is it going to be limited to vital elements or cruise missiles as well? Perhaps we need to clear up our understanding of where we can use this kind of missile. Well, I can give you a kind of simple-ish answer to that. It's not a question of technology, technique. It's a question of principle. Here in France, we want to make a very clear distinction between technologies which are used in dissuasion from those that are used in the conventional battlefield. And there are different signatures in dissuasion or conventional warfare in the future. If we have to have hypersonic missiles that are in France, then it will be a nuclear missile. And while we're taking this position, there will be no hypersonic cruise missiles, so that there is no confusion. It's a signal which we're sending to our enemy on the nature of our intentions. And that was true for the SIMPA, SPA. This has always been the case. Well, I just have to thank you all. We haven't got those recorded messages which wrap up our session, so I have to do that personally. Thank you very much. We've examined this issue from many angles. Thank you to my panel members.